All good.
Sure.
Good morning, good afternoon, depending on what part of the world you're in. Thanks very much for joining us. I am here with Michael Schachter, who's the Director of Product Marketing at Allot, which is a cybersecurity company in Israel. And Michael has very kindly agreed to give us an overview of Allot with specific reference to Allot 5G Net Protect. So thanks very much for joining us, Michael. If you can introduce yourselves and share your desktop, that would be great.
Yeah, okay. So happy to be here. And as mentioned, I work at Allot, which is a company that deals with cybersecurity solutions in mobile and fixed networks, selling to service providers pretty much all over the world. And as mentioned, I'm Director of Product Marketing, and I'm also joined here by Itai Glick, who is our AVP of Product in charge of our network security products. So we'll just jump in and hope that you all see the screen clearly. We'll be talking just for a few minutes about 5G Net Protect, which is our solution for securing and protecting the 5G network. And as we'll see, 5G, along with all the promise that it brings for exciting new applications, also has some built-in vulnerabilities that we feel need to be addressed right at the start by service providers, so that they can in fact deliver on the very real hype and abilities that 5G brings to the market. So we'll give a short overview, a little bit about the company, a very high level look at the use cases that I'm sure you're all familiar with, and then a short overview of our solution, why it's needed, and what's special about it. So jumping right in, Allot is a company that's been around for more than 20 years, and we have leading network intelligence and security solutions. So we're both in the cybersecurity area as well as the network intelligence, and of course they're very, very connected, because you've got to have deep intelligence and insights into what's happening in the network in order to be able to secure it. So we bring sort of those two worlds together. And our main target audience, our main customer base is the service provider space, as well as enterprises, because many enterprises have networks that are very similar in scale and in the need to deliver secure and intelligent network solutions for their users. And so our applications and our solutions apply to them as well. So we sell to communication service providers, as I said, around the world, mid to large enterprises. We're involved in some of the really cutting edge 5G implementations, both in the United States as well as in Japan. So kind of spanning the globe. A wide customer base, as befits a company that's been around for 20 years, a global presence, and very nice financials, as you can see in the numbers there moving forward. So let's talk about 5G for a minute, the benefits, but also the threats, and that's really kind of, as you'll see, why we believe that there's a strong need, and our solution kind of fits that need, sort of like a glove to a hand, as it were. 5G, the hype is out there. It's all about these three pillars of enhanced mobile broadband, right? So the ability to really deal with huge amounts of data at high throughput, enabling all kinds of advanced video solutions and services, augmented reality, all of those big broadband consuming services. But then there's also the massive machine type communication. So that, gets us into the whole IoT world, where you're now going to have, orders of magnitude higher density of these so-called smart devices, IoT devices of all kinds and shapes, whether it's smart city traffic lights, industrial monitoring, web cameras, robots, remote medicine, cars, everything. And so the devices are very smart about what they do, but they're not so smart about security, and we'll get to that in a second. And then the third thing, which is in some ways maybe easiest, to wrap our heads around in terms of the changes, and that's this ultra reliable, low latency, the ability and the need to be able to react incredibly quickly to all kinds of monitoring and measurements, augmented reality, and I think the use case that has everyone excited is autonomous self-driving cars, where it's very easy to understand the the critical need for really fast, really low latency response times, because obviously vehicle approaching rapidly on your left is not something that you want to get hung up with a delay in the responsiveness in terms of automatic reaction time. So, there's a whole bunch of different use cases here, and some are closer to the massive broadband, some are a mix of broadband and low latency, and they may involve the machine type communications. Again, the car being an example, you might be, having your kids watching a movie in the back seat while you're automatically driving and needing this incredibly responsive time. So that's 5G, that's the promise, that's the use cases, at a very high level. We're all excited, service providers, the end users, and solution vendors like ourselves. So what's the issue? What do we need to concern ourselves about? And that is the underlying thing of skyrocketing performance and scale. That's all well and good, but, and here's a big but, in order for 5G to be able to realize this dream, the architecture of the mobile network has changed, right? We can't have all the inputs coming and going all the way from the radio access network into the core, across the core, out to the out to the internet, and then back. That's not going to work for many of these solutions. And there's going to be, all kinds of IoT devices. And I hinted at the problem there. I think, anybody who's involved in the telecom industry knows that, and even, the mass consumer market, we're all aware that IoT devices are often hacked. And we've all seen, the horror stories of the child, security camera suddenly starts talking to your kids or is recording you in your house, and so on. And these are real stories. And the issue is that a lot of IoT devices are very specialized for their function without a lot of thought to security. And so there's often, zero or minimal security default passwords that never get changed. And now we're talking about massive numbers of these IoT devices, many of which will also be high capacity devices. So we've suddenly got this huge number of potentially weaponized devices out there that can, be enlisted into these bot armies of massive, bombardment of your network. So that's a problem, right? And then, as I mentioned, because of the need for the low latency, the architecture has changed, and so now we've got these mobile edge access connections, so that for quick response time, you don't need to go all the way through into the service provider core to get at the other end, but rather there will be hundreds or thousands of these MEC points for quick access to the internet and response back to the device. And that means that networks have many more points of vulnerability where attacks can take place. And so there's more devices, and there's more access, and there's more danger. And that gets into the whole network side of the problem. And so the network is more vulnerable, and you need now to be able to address that vulnerability. So we've got the growing DDoS threats. We've got the need to assure services across 5G because promising high definition video is only as good as the quality of the video that you can really deliver. And during during times where there are no attacks going place, but congestion may be growing on the network, which perhaps won't be a problem, day one with 5G, but we've seen with every technology that if you if you build it, they will come, and we're going to get to that point of congestion. So you need to be able to assure high quality of all your services. The infrastructure, as I said, is now much more sensitive because you've got all of these points of access that you didn't have before. You've got the massive IoT with the high broadband ability now to be subverted and bombarding you. The latency can't be compromised. You've got to deliver on latency. So any kind of even low grade, let's say denial of service attack could put latency at risk. And this whole cloud native architecture is also something that you really need to be able to deliver solve these problems. So this slide kind of both summarizes the problem domain, but also talks about why our 5G net protect solution is geared to solve these problems. Because it is cloud native, it will fit into your 5G architecture. Because it has the inline deep packet inspection, it has the ability to detect that threat traffic is starting to build up in your network, and it has the ability to recognize the threat and to be able to mitigate the threats wherever it occurs in the network. So that means you've got sensors near the MEX as well as in the core, and you'll be able to detect these problems wherever they happen. You'll be able to mitigate the DDoS. You'll be able to see when bots are starting to, or when IoT devices are starting to misbehave. They may be in the process of being recruited for botnet attacks, and you'll see that their behavior has changed, and you'll be able to isolate them. And so this combination of DDoS protection and botnet mitigation really gives you a kind of an end-to-end network protection. And again, going back to our inline deep packet inspection, not only are you seeing and recognizing change in traffic that could indicate an attack underway, and then enables you to detect the pattern and mitigate it immediately, it also lets you see the different services and the different SLAs and the different kind of subscriber groups that are involved in service consumption, and make the bandwidth adjustments to ensure that you're meeting these SLAs even while under attack, and certainly while under situations of congestion. So we believe that this distributed cloud native architecture with the inline mitigation and QoE assurance will give 5G service providers the best ability to respond and to secure the network automatically as problems develop. So that's pretty much, in a nutshell, our solution. I think I've given a sense of why 5G networks are more vulnerable, and how an inline protection system is really best geared and best adapted to solve these problems for service providers. So that's what we wanted to get across here. I hope it's clear, and certainly, Henry, if you've got some questions, we'll be happy to take them.
Fantastic. Thanks so much, Michael. Very interesting. Yeah, I do have a bunch of questions. I've got literally, there's like 4 or 5 questions here. The first one is, I'm just curious, when is 5G meant to be rolled out for everyone? Is there a date which is like a rough date by, I don't know, 2022? Is the world expected all to be on 5G at some point in the future?
Yeah, so from the kind of reports that I've been seeing and that are out there in the industry, it's not going to be it's not going to be everybody by 2022, but it's going to be the fastest rollout of technology that we've seen. 4G was much quicker than 3G, and 5G will be quicker than 4G. I think they're talking about 2025 everybody will be there. But there will still be a lot of 4G, certainly through 2021, 2022, but it'll be, rapidly shifting over the next, I guess, four years or so.
Okay. Have you heard of a tool called Shodan? Are you familiar with Shodan? It's like a it's like a search engine. Which
I'm not, but
it's like a search engine that's uses Google Docs and so on to find vulnerable IoT devices. So just like you said in your presentation, we've all heard the horror stories of the webcam which you can sort of hack into, right? So my question is, do you use kind of open source intelligence to find vulnerable, devices that you can then lock up? Is that something that you do? I'm just curious.
Yeah, we are familiar with that tool. This is Itai here.
Okay, hi Itai.
Yeah, so I mean, we have a combination in our solutions of using threat intelligence, but one of the additional things that we do is, because of our inline technology, as I mentioned, we put a lot of emphasis on recognizing change in behavior. And so typically, we can't be out there necessarily stopping somebody from trying to subvert a bot device through, let's say, the example that you gave of the Google Docs. But once the device begins to misbehave, and misbehaving could be things like, suddenly communicating with different IP addresses than it typically has been communicating with, or communicating at a different, volume than it's been communicating, or at different times of day. Those are all, symptoms of enlistment in some kind of, malicious activity. And so what we have, tuned our inline DPI capabilities is to spot those as soon as they start happening, and then to quarantine those devices. So it doesn't stop it at the, we can't be out there seeing the recruitment happen, but we can see the very initial changes. And we've got solutions that are doing that in tier one, North American networks, to keep enterprise devices only, it's almost like a firewall kind of approach. They're only allowed to communicate with the IPs that they're meant to communicate with. And so if you know that a priori, that's one way to solve it. But if you don't know it, then the, detecting these changes in behavior is key to keeping your network safe.
Okay, cool. In fact, you've kind of, I think you've answered my next question, but I'm going to ask it anyway. Why is it important to have inline solutions on the network? Why is it important to have inline solutions on a network?
So there are a number of different aspects to it. One example I'd like to give is from a real life, a couple years ago, there was the Memcache DDoS attack, which brought down some pretty big networks around the world. And our solution detected it, recognized it as, non-normal traffic, and captured the pattern, and was able to remove that traffic from the network within, seconds to minutes, without knowing that there was such a thing as the Memcache attack. It was before it had been diagnosed. It was before it had been publicized. But because we were in line, and because we work by benchmarking normal traffic and then detecting, suspicious pattern changes, our system automatically, without any need for operator intervention, cleaned Memcache off of our service provider customer networks, day zero. So that's one example. The other example that I mentioned is, 5G is being pushed and hyped, and justifiably so, as very SLA sensitive, very service-based architecture. You need to be able to see the applications that are being used. You need to be able to see that the services are or are not meeting their QoE commitments and the SLAs that underlie that from a business perspective, in order to be able to kind of fine-tune bandwidth allocation, even beyond or even within a service slice. There may be different applications competing for resources. And as I said, 5G will become congested just like every other technology, even though the pipe is so much bigger. As it becomes widely used, people will find ways to use it up. And so again, only if you're in line can you actually see the traffic that is competing for competing for network resources and be able to automatically, again, fine tune that. And the third thing was the one that as you said, I already mentioned, was that detecting bots as they're starting to try to come online and become problematic, and be able to isolate them. You've got to be in the traffic, in the pipe, to see that happening and to react to it.
And is that being in the pipe to see it's happening? Is that you spoke about deep packet inspection. Is that one of the benefits that you guys offer? Like being able to actually, do deep packet inspection?
So absolutely, no, absolutely.
Okay.
Yeah, so in order to do all those things I talked about, which is to recognize, the kinds of applications, the kinds of traffic that what's actually going through the pipe, to be able to spot, malicious activity, requires being in the data and actually seeing the packets, and seeing their behavior, learning to recognize, increasingly through kind of machine learning technologies, because as traffic becomes increasingly encrypted, it's more challenging. And so we've got, researchers doing that work in the back office to be able to implement this kind of artificial intelligence, which lets us still see and understand the traffic, even though the encryption is going on increasingly. But so yes, you need to be there to be able to see it, to be able to react to it, to be able to bring those benefits to bear.
Oh, excellent. That's pretty much exhausted all the questions I had. And thanks very much for your time, Michael. Really appreciate it.
Yeah, our pleasure. And it's an exciting time. It's an exciting, there are these great opportunities for the service providers and these new applications that I don't think we can even imagine yet. But like I said, it's a new network, it's a new technology, and there are a lot of vulnerabilities that need to be addressed in order to actually be able to deliver. So we're here to help our customers and help everybody enjoy the benefits of 5G. Fantastic,
and we'd like very much to spread that positive message far and wide. And thanks again for your time, Michael. I appreciate it.
Pleasure.
See you.
Bye-bye. Cheers.
Thank you, Henry.
Thanks. Thanks, guys. Bye-bye.